My friends, welcome back to another episode of 200 3D CAD models in FreeCAD series. Today I want to work on exercise 74. Now exercise 74 is a little simpler, so I'm thinking maybe at the end, if I got time, I'll do an FEM analysis on this model because as I mentioned earlier, I have an eventual target to be proficient in FEM on different models. Having said that, I want to start working from the front face, which is in my opinion XZ plane. Let's put that on XZ and let's go to front. There it is, there. And I want to bring the AC axis cross back. Now that I can see the axis cross right here, I want to move the image. So maybe at the center of this hole, there. Let's take the axis cross away by pressing AC on the keyboard. And now it's time to draw our first sketch. Let me go ahead and then do this one on part design workbench. So for part design, first thing first, create a body and then create a sketch on XZ plane. There, hit OK. Now I want to with a center circle, which will be about 30 millimeter diameter, and then I want to start with these two rectangular portions. Let me put that rectangle right now, and we'll come back to fix them later. So I want to take this line away and this line away. Then disconnect this. Nope, that's not what I wanted. I want to disconnect this dot from this line here. And maybe I want to place this point on this. Not right now. Let's do the same thing on here and bring it back. Now I want to start with a couple arcs. I can take the arc from here. I know the center points and end points. So take the center points, end point. Do the same thing on this side. Yeah, that's our sketch. Now all we have to do is constraints, apply some constraints. So inside diameter would be 15. This is 25 radius, 25. And I believe these two will be equal. This two will be tangential. And this. The only thing left to do is applying these two as equal to 10. Now when FreeCAD, the next person comes in, applying these constraints will be much easier. So until that comes to reality, 2 will be equal. So that's our full sketch. Got this sketch in here, and what I want to do is I want to make it an extrusion. So make a pad over the whole 40 millimeter gap. Go ahead and then rename this sketch as sketch A. Okay, that makes sense. So let's go ahead and then make a pad, right? I want to make it symmetric and keep a length of 40 there. So since I made it symmetric, 20 will come towards me, 20 will go away from me. So that's total 40. Now we have to do some more finesse, final touching. One of them is to make this notch in the middle, which should be easier. So this is XY plane. Now this is XZ plane. This is XY plane. This YZ plane. On XY plane, I want to make a notch and I want to make a hole. I want to make these two round corners. So let's go ahead and then apply our image to XY plane. and then I want to align our object with this top view. Take that as an OK. So what I want to do, I want to in sketching on XY plane, but I don't want to sketch it on this face. I don't want to map it to avoid any possible topological naming issue. I keep hearing that there will be a much more efficient solution to this topological naming issue in the next version. So until that version comes in, let's um, follow our standard practices. I want to create a sketch on XY plane, not mapping on anything. And I want to turn on the section view. So what I want to do, I want to draw this rectangle. I want to draw this circle. I don't think I can do this one on this, but we'll give it a try. Let's take a rectangle, place it in here, take a circle here, and for this one it will be a negative, so I can do arc. We'll give it a try, see if it works. Make that right. That's all the drawing. Now I want to constrain them. It will be symmetric to this axis. It will be length 40. This is 30 millimeter away from the axis. This length would, that part is constrained. This diameter will be 28. So radius 14. This is 50 millimeter away from this axis. Right? And this diameter is, so radius is 20. Right? Radius. All I can do is I can make tangent there. That's fully constrained. So that's our sketch, which I want to make. Sketch will be, and I want to make a hole, so pocket. Let's go with more specific terminologies. I want to make a pocket. I don't see anything because it's not crossing anything. I want to say, I want to through all. That took it downward. To make it symmetric to plane, that will take it upward as well. So that's our object. Actually, having these corners, making them corners in part workbench would be a bit different because this method would not work in there. So I'm going to say for this model, our design is better compared to part workbench. Anyway, that's our object. Now, as I mentioned, I want to make a little bit of FEM analysis out of this model. So let's go ahead and save it up first. So for FEM, we need one object, which is by default in part design. We comes as in one body, one object. Now I want to go ahead and then go to FEM analysis. Then, so first thing first, container for analysis, and then insert solver. These are the way to turn on the light bulb. I don't know much about FEM, so I'm just following like a technician. Okay, So I apply material. So I'm going to go ahead and say aluminum or material. And then I want to apply some constraints. Now, one thing I am struggling is to apply different types of support systems, and I only can apply the constraint fixed, so fixed object. Now I want to say this is the fixed part. Say if there was a bolt, this would be the part that would be fixed. Okay, and next thing I want to do is apply some load. So I want to apply load on entire surface, right? I want to go ahead with pressure, add this surface, right? Okay. So we got the support, we got the load or pressure in this case. And the last thing I need to do is make a mesh. So select the pocket, create a mesh. Go with maximum 100. Bye. Hopefully this will work. So we got the mesh, got everything else. So we got the analysis container, we got the solver and material and support system, load system, and then the mesh. And then write the INP file and then run calculate. So red line it says calculate execute error, which means it didn't work out, and that is problematic. Okay, we will go with the other mesh, mesh, and I'm just going to leave them auto. Hit apply. Okay, then let's go to the solver tool again and run calculate. Oh, calculate's done without error, and that's all I was looking for. So double clicking the CCX results will give us the option to visualize the magnitude of displacement and different other stresses. So we can see right away that there will be 13 millimeter displacement in this object, the way we set it up. So we can see that from here. Click show displacement and see how it moves. Okay, I need to turn off the object and on. Then go back to CX results. So this is the mesh. So here we can see this object will be displacing. The most displacement will come at the red where it says red, and there is a fixed support, so it will still be displacing near the support as well. Had I made this surface fixed, so we would not have any displacement in there, but the way our support system works now, there will be a little displacement in here. This circular portion did not show much deflection itself, so the whole thing is moving, but it's not displacing this entire circular shape. So the circular shape is not becoming oval shape. That's the point. But this entire area moving, the way it's moving, I guess the most stress will be coming here. This bar is not bending at all, as you can see. The most bending is coming in this area, so I figure there will be the most stresses. So let's see if that stress guessing is oh wait on me. Okay, yes, I can see that most stress is coming in this area. So where the most displacement is, the stress is not the maximum there. Where the most bending is, there the displacement, there the maximum stress is. But I'm happy that this FEM analysis worked out pretty good. As I said, I'm still getting my feet wet into the realm of FEM analysis in FreeCAD, and this model was a good example to get my feet wet. I hope you liked this video. I will see you in the next video. Thank you for watching. Bye.